Intermediate Algebra, Section 5.2, Multiplication of Polynomials. Just like numbers, polynomials can be multiplied. We begin by finding products of monomials. To multiply two monomials, we multiply coefficients and we multiply variables using the rules for exponents and the commutative and associative laws. With practice, we can work mentally, writing only the answer. I want to put these coefficients together and the variables together. I can rearrange this multiplication using commutative property, and this is what we're talking about mentally. We can do that, but to show what's happening, I've written it out and then simplify. 3 times 2 is 6. X times x can be written as x to the second power. This is no different. It's a monomial times a monomial. We can use our commutative property to rearrange the values to put like terms together, a negative times a positive. For our integers, 6 times 5, 30, and common bases multiplied together, we add the exponents. And again, mentally, hopefully at some point you can do this without writing it down, but to illustrate that, I've written it. This one, we have a monomial times a binomial. We're going to use the distributive law here as the basis for multiplying polynomials other than monomials, which means every term inside the parenthesis is going to be multiplied by this term or monomial out in front. So we'll have x times 3x with that sign, x times 4. Cleaning this up using your commutative property and common bases, we'll write that as x to the second. Typical, we put our numerical coefficient first and then the variable or variables second for a monomial. Same thing here. In this next example, we have a monomial times a polynomial. So we will use distributive property. Each one of these terms is being multiplied by that quantity. So we'll have negative 2b squared z times the first term. And I'm going to write this out, but we could do this mentally. But just to illustrate what's happening, so we'll take that front monomial and multiply it by the second term using the sign, and then that front monomial times the last term. Then it's a matter of cleaning these up. I have a negative times a positive. 2 times 2 is 4. Nothing to alter the b squared. We have a z to the first times z to the second will give us z to the third and the a. We have plus a negative times a positive is a negative. You can either write it as plus a negative the quantity or a subtraction. There's only the 2 for integers. B to the second times b to the first gives us b to the third. We have a z times z is z to the second, and we have the a, pardon me. Here we have a subtraction of a negative times a positive. Minus a minus is a plus. We have a 2, b to the second times b to the first. If we use commutative property and simplifying, we end up with b to the third and then a z. The order of these variables has no rule for that. I'm simply going left to right just to make sure I'm not losing any of those values as we go. In this next example, we have a binomial times a binomial. We could do a double distributive, taking 3 times each one of the quantities and then x times each one of the quantities. But we've simplified that into a concise method that essentially is what I just described, and this is called the FOIL method. And this is from the class notes for sections 5.1, 5.2. We use the FOIL method. If you have a binomial times a binomial, we start out by multiplying the first terms together. That's the f. And the first terms are here. It's the first terms in each of the binomials. Next, we will do the outer terms, and by outer they mean the kind of gatekeepers, the beginning and the last. So there's our outer terms. That will result in an a times d. Next, we do the I, which is the inner terms, the terms that are right next to one another in the middle. And for the L, that is for the last terms for the FOIL method. And by last terms, they mean the last terms in each of those binomials. So that would be the B times D. So using the FOIL method here on this next example, we'll start with the F for multiplying first terms together. X times 3x is a 3x to the second power. Next is O for outside. X times a negative 4 is a negative 4x. I comes next. That's the inner terms. Positive 3 times 3x is a positive 9x. And then L for the last terms. The second term in each of the pairs, 3 times a negative 4 is a negative 12. Simplifying if possible, and we do have similar terms. Nothing to combine with the highest power. Negative 4x plus 9x are similar. When we combine those, we end up with a 5x and then a minus 12, our constant term. It's typical to express our answers in decreasing powers of x, as I have here, or the variable, whatever it happens to be. Now I'm drawing the lines to illustrate the FOIL method. At some point mentally, you can look at a binomial times a binomial to write your answer down, and even holding these middle terms together, the O and the I, and resulting in just adding the 5x, putting that down as a simplified answer. This next one is still a binomial times a binomial, which means we'll use the FOIL method. And again, I'm going to draw the lines just to illustrate what I'm doing. 3y times 4y would be a 12y to the second. Outside terms, we have a positive times a negative, a 3y times 1/6, and I'm going to write that and come back and simplify it in a minute. We have the inside, a negative times a positive is a negative, 1/4 times 4y, and then the last terms multiplied together, a negative times a negative is a positive, and we have 1/4 times 1/6. Don't let the fractions stop you. I've written them. We'll go through and simplify those now. We have a 3 times 1/6. It's actually a 3 over 1 times 1/6 would be a 3/6 or a 1/2 y. 1/4 times 4, these are reciprocals. They cancel out, leaving a 1. And when we multiply fractions together, we multiply numerators and denominators, which gives us a 1/24. We do have similar terms here. A negative 1/2 plus a negative 1 is a negative 1 and 1/2, or 3/2. And I think I'll write it as an improper fraction, negative 3/2. We could have written it as 1 and 1/2, or 1.5 for that matter. So there is the simplification of that binomial times a binomial. Let's take a look at this next one. This is shorthand for this binomial times itself. Anytime we have something to the second power, if we rehydrate this, this is short for x plus 2, which means we're going to use the FOIL method to simplify this. Multiplying first terms together, we get an x squared. Outside terms is a 2x. Inside, when we multiply, is another 2x, and last term, 2 times 2 is 4. Simplifying, we end up with an x squared. Add these two together, since they're similar, as a 4x, and our constant term is 4. A lot of students will look at this and think it's simply x squared plus the 2 squared, but they're missing the outside and the inside multiplication there. At some point, if you recognize this and what the answer is, you can square the first term, square the last term, that's right, but to compensate and make sure you include the outside inside, when multiplying these two binomials, you can multiply these two together and double them. Whenever you have a perfect binomial square, that's a shorthand for the result of multiplying it out the long way. So let me show you the shortcut here, and then we'll illustrate that. When you have a binomial squared, which means x minus 4 times x minus 4, shorthand is square the first term. If I'm putting these in decreasing order, I will multiply these two together. So x times negative 4 is negative 4x. Double that, which means multiply it by 2, which gives me 8x, and then square the last term, which is 16. Let's see if that shortcut worked. Multiplying first terms together is x squared. Outside is a negative 4x. Inside is a negative 4x. Negative 4x plus negative 4x is negative 8x. And last terms multiplied together is 16. As we're multiplying, you should be thinking, and maybe you shouldn't, but I'm going to tell you, you should be thinking about, we are going this direction. Think about what you end up with. Before long, we will be looking at factoring, which is the fancy name for division. We will be given this and asking you to pull it back into what it originally was multiplied together as. So looking at these patterns helps us with our factoring that's just around the corner. And that brings to mind here why I mentioned this. When I look at these two binomials that are being multiplied, they're exactly the same except for their signs. And let's see what happens when we multiply something that looks like this. First terms multiplied together, x squared. Outside terms multiplied together, a positive times a negative is a negative 3x. Inside terms multiplied together, positive times a positive. And last terms multiplied together, positive times a negative, gives us negative 9. Simplifying, there's nothing to combine with the x squared. These are the only similar. They're additive inverses or opposites. They cancel out, leaving us with a negative 9. So even though it was a binomial multiplied together, which means you could have a maximum of 4 terms, we could have 3. We've had several that have 3 terms, but here's the special case. When you have a binomial times a binomial, and the only difference is the sign, you end up with 2 terms. And if you look, this is a square and this is a square, and we actually call this a difference of squares. And when you recognize that's what you're going to end up with, you can save yourself the outside-inside step because you know that they'll cancel out. We call these conjugate pairs. And they come into use in several applications that we'll see down the road. This next one is a binomial times a binomial. If you do an inspection, look at here, they're exactly the same except their signs are the opposite. I have a sneaking suspicion that the middle terms will cancel out, but I'm going to go through and illustrate all the FOIL method and then see if that is the case. So we have a 2xy times 2xy. That brings us up to a 4x squared y squared. Outside terms would be a 2 times 3 is 6xyb. Inside terms, a negative times a positive is a negative. 3 times 2, when we rearrange those, we have an xyb. And these are similar, but when added together, they cancel one another out. The L of our FOIL method, negative times a positive is negative. 3 times 3 is 9. B times B is B squared. And it did happen on this problem as well. The middle terms canceled out. We were left with actually the square of the first term and the square of the last term, but a difference of squares. In the next one, got fractions, but look at your binomials. They are the same with the exception of a sign. We have conjugate pairs. We'll end up with difference of squares. So when we multiply first terms together, we will have 5x times 5x or 25x squared. Outside, we will have a 5 times 1/2, which is 5 halves x. inside a negative times a positive. 5 over 1 times 1/2 is a negative 5/2 x, which when added together cancel out. But we still have our last terms. A negative times a positive is a negative. 1/2 times 1/2 is 1/4. So there is the result of those binomials. Doing some further multiplication, we have again this shorthand. 2 routes to go. Either write it out so you don't lose any aspect of multiplying a binomial times a binomial, and that would result in a 4 times 4 is 16. Outside we will have a negative times a positive. 4 times 3 is 12, b to the second. Inside a negative times a positive, 3 times 4 is 12, and the b squared. And then last terms, a negative times a negative is a positive. 3 times 3, 9, b squared times b squared. Add those exponents gives us to the 4th power. Simplifying this, we have a 16. These are similar terms. A negative 12 plus another negative 12 is a negative 24. B to the second plus 9b to the 4th. Remember, when you're adding, you're looking for similar terms and you only change the coefficients. The powers do not change. The only time a power is going to change is when you're multiplying. The shortcut is when you have a binomial squared, if you recall from a couple problems back, I can square the first term. 4 times 4 is 16. To generate the middle term, you multiply these two together. So we have a positive times a negative, which is a negative 12b to the second, and double that. Negative 12 doubled is negative 24 with the b squared. And then the last term is this second term squared. A negative times a negative is positive. 3b squared times 3b squared is a positive 9b to the 4th. So your choice, whatever you're comfortable with. Next, when we have a binomial times a trinomial, you have a couple options. You can use your distributive property, which would be ignoring the first term, and it doesn't matter which order, quite frankly, but if I ignore the x and just treat this as a monomial times this binomial, we will have 3 times each one of those terms. So we'll have 3 times 2x squared. We'll have a minus 3 times x. We'll have a 3 times the positive 5. Then ignore the 3 and distribute the x times each one of those. So now we'll have an x times 2x to the second. We'll have a x times this minus x, and I have my minus there. And then finally an x times this positive 5. Simplifying, I have a 6x squared, and again you could have simplified this on the fly, but I want to show what the distributive 3 times each one of the terms, x times each one of the terms looked like. Simplifying here, I'll put the numerical coefficient out in front, and x times x to the second is x to the third. Here we have x times x, or x squared, and then the 5x. If we simplify this and put this in decreasing powers, I'm going to put the 2x to the third first. There is only one of those. Next, I'm going to combine the squared terms. We have a 6x squared minus 1x squared. 6 minus 1 will leave us with a positive 5x squared. Next, we have a minus 3x plus 5x. 5 minus 3 is a 2x. And then we have our constant term of 15. The other way that we can handle that problem is to treat it as though it were similar to a 2-digit times a 3-digit number. If you had 124 times 71, think about how you would multiply those numbers, and we can treat this the same way. So here's method 1 using the double distributive, and here's method 2 if you like the vertical version. Let's show you what that looks like. So I'm going to put my trinomial on top, my binomial below, and I'm going to multiply these. So just like if you were multiplying whole numbers together, I'm going to take a positive 3 times 5, which is a positive 15. 3 times negative x, a negative times a positive is a negative 3x. And then 3 times 2x squared will give us a 6x squared. I'm done multiplying the 3, and if you notice that's what we just did here. I'm going to shift over to the next value or term. I'm going to take b or x times each one of these terms. X times positive 5 is a 5x. I'm going to line it up with its similar term just to make it easier when it comes to simplifying our answer. Next, we'll take x times a negative x here, which gives us a negative x squared. We'll line it up underneath the similar term. And last, we have to take x times this leading term out here, which is going to give us an x to the 3rd power. I don't have a 3rd power, so I'll stick that out in front. Ultimately, we end up with a 2x to the 3rd power. And just like with multiplication, we are going to add these together, our like terms. So we have a minus 2x to the 3rd. 6 plus a negative 1 is a positive 5x to the 2nd. Negative 3 plus 5 is a positive 2x, and the 15. And here we have the same. This shouldn't be a negative. I don't know where that came from. My bad. When we add these together, we should have the same answer, and we do. If I hadn't introduced a subtraction sign from who knows where. Be on guard when you do tend to relax when it's something easy, multiplying. We do tend to introduce signs or drop signs. So always be diligent and on the guard for those occurrences and try to avoid them at all costs. Here we have a trinomial times a trinomial. It's your choice whether you want to do the distributive method here or whether you set this up vertical. It's entirely up to you which method that you want. I'll do the I'll call this the horizontal or the distributive method. I'm going to start with taking negative 1 times each one of these terms. So I'll have a negative m, a negative n, a negative 1 when each one of those is multiplied by negative 1. Next, I'm going to take n times each one of these. So we'll distribute the n times each one. That will give us an mn. And n times n, or n squared, and n times 1 is n. And then I'm going to take m times each one of these. So distributing the m times m will give us an m squared. M times n is an mn, and m times 1 is an m. Now it's a matter of just cleaning it up. As far as decreasing powers, maybe in some instructions they would tell you we want it in decreasing powers of m or decreasing powers of n. Not real clear here, but let's just combine like terms and simplify it, and let's go with decreasing powers of m. So I'm going with m squared first. That term is off the plate. The next term that's similar, that has m and n, and really the order isn't that important here. I have a positive 1 mn and another positive 1 mn, which makes 2 of them. M's by themselves, I have a minus m here and a positive m there, which they cancel out. If I put my n terms together, I have a minus n plus n. Those cancel one another out. I have a minus 1, and I have the n squared. We already took care of our m squared in the lead. So there's the result, and you could have set this up and had a vertical multiplication with this trinomial times that trinomial. When we're doing our multiplication, and it doesn't matter if it's multiplication or any math, always order of operations should be in the forefront of your mind. So looking at this expression, you consider simplifying inside the parentheses. Can't do that. Next order of operations is powers. This has the priority. It's this binomial squared. Then we would do the implied multiplication, and finally we would do the subtraction. How you handle this, that's totally up to you. I'm going to write it out in expanded form and do the multiplication using FOIL method. First terms multiplied gives us an x squared. Outside would give us a 4x. Multiplying the inside would give us a 4x, which adds up to be an 8x. And last terms gives us a 16. That's the result of the first binomials, minus this whole product. And what is that whole product? Let's see. Using the FOIL method, multiplying first terms together gives us an x squared. Outside multiply positive times a negative is a negative 2x. Inside gives us a positive 2x. When we add those together, they're gone. Last terms multiplied together, a positive 2 times a negative 2 is a negative 4. We lost the middle terms, and if you look, we had conjugate pairs. We had the same binomials. The only difference was their signs, and we're starting to see this pattern that the middle terms cancel out. So it's a subtraction of this quantity. In other words, to deal with subtraction, we can change the signs and add. Take the opposite of that. So I have an x squared plus 8x minus 16. The opposite of x squared is negative x squared. The opposite of negative 4 is positive 4. And you can see that if you take a negative 1 times a negative 4, you get your positive 4. Now, it's a matter of just combining like terms. X squared minus x squared cancel one another out. We have an 8x, nothing to combine with that, and a negative 16 plus 4 leaves us with a negative 12 for our answer there. The last problem is to take a look at functions and multiplication. Here, they're giving us the function f of x is defined as that polynomial. We're looking to find f of t plus 2, and that means wherever x is, we are going to replace that with this t plus 2. So in this function, we're going to take 2 times, and it's only the x that's raised to the second power, and we are substituting x with this binomial plus x, so we'll put the t plus 2 in its place, and then the rest of the function. Sorry about that. I apparently not moving enough, and the lights just turned off on me. Now, similar to the last problem, we need to think about order of operations. We have a binomial squared would be our priority, then we'll take care of multiplication, and then any addition and subtraction. So temporarily ignore the 2. We're taking t plus 2 quantity squared, and whether you write that out as a t plus 2 times t plus 2 and do your FOIL method on it, or if you do your shortcut, we'll both end up in the same way. We ultimately, by writing it out, I have 3 things multiplied together. We can only multiply 2 things together at the same time. My suggestion would be to multiply the binomials together first and then multiply everything by 2. Multiplying first terms together, we would have a t squared. Outside would be a 2t. Inside would be another 2t, which gives us a total of 4t. And last terms would be a 4. The parentheses here are, because it's addition, aren't having any impact. We'll next do our distributive. Everything inside the parentheses is going to be multiplied by 2. And then last step, we will combine like terms. Nothing to combine with the t squared. We have an 8t plus t is a 9t. And integer-wise, 8 plus 2 is 10 plus 1 more is 11 for our final answer.